In this problem, I will be using dimensional analysis to convert two rates. We are told that dopamine 400 milligrams is contained in 500 mLs of D5W and that it is infusing at 30 milliliters every hour. What we need to do is to calculate the dosage that the client is receiving. The first thing we need to do is to figure out how many micrograms the patient is receiving every hour. And then we need to figure out how many micrograms they're receiving every minute. So what do I know at this time? I know I'm converting rates, but I'm also told that the patient is receiving 30 milliliters every hour. So that's the rate. If I start with part A here, that is the rate that I know. So the rate that I'm starting with is 30 mLs per hour. What I need to figure out when I'm done with my dimensional analysis, I need to have a unit of micrograms in the numerator, and I need to have a unit of hours in the denominator. I see that I have hours already. So I don't need to convert anything with hours. I don't need to change it. I already have that. But I also see that I need to change milliliters and figure out, well, how many micrograms they're receiving. Notice in this problem, we don't have a direct conversion between milliliters and micrograms. What I do know, however, is that the patient is receiving a certain number of milliliters, and those milliliters have some milligrams in them, milligrams of dopamine. So what I can do first is determine how many milligrams the patient's receiving. And since milligrams is in the same metric system as micrograms, I could quickly go from milligrams to micrograms. So let's cancel out milliliters. Let's get out of milliliters. And according to this, the only way I can get out of milliliters, or the only thing I can convert into directly from this problem, is milligrams. So with my one step here, I see that I could write 500 milliliters, and the conversion factor here is 400 milligrams. And if I were to stop right now, at this moment, milliliters would cancel, and I would know the total number of milligrams the patient would be receiving every hour. Milliliters would cancel, I would know milligrams per hour. But that's not what I want. I want micrograms. This is good though, as I had mentioned, because these units are in the metric system. It's a quick conversion. You need to know that 1 milligram is 1,000 micrograms. And from here, I can see just with that additional step, I can now have a unit of micrograms in the numerator and hours in the denominator. If you multiply those numerators, so if you take 30 and multiply that by 400 and multiply that by 1,000, you're going to get a large number. It's going to be 12 million. So 12 million, see if I can squeeze this in here. And in the denominator, you're going to have 500. So if you take 12 million and you divide it by 500, you're going to get 24,000. 24,000, and the unit will be micrograms per hour. So I knew the patient was receiving 30 mLs every hour. I was able to convert that to milligrams, and then from there I was able to convert that to micrograms. I see that the patient's receiving 24,000 micrograms every hour. I could use this information for part B. Part B says, well, how many micrograms is that every minute? Well, if I know they're receiving 24,000 micrograms every 1 hour, I can convert hours into minutes, and that can be done pretty quickly. Using a dimensional analysis approach, I can cancel out hours, knowing that 1 hour is equivalent to 60 minutes. And knowing that means I can write that as a conversion factor, and that's it. If I were to stop right now, I would know the total number of micrograms per minute, which is what I'm looking for. So doing that division, you get 400. And the unit is micrograms per minute. You could have also kind of started over. Knowing 30 milliliters per hour, you could have started with that, then converted the milliliters into milligrams, milligrams into micrograms, and hours into minutes, you could have certainly done that, similar to what we did in Part A. But since we already were pretty far along after completing Part A, we knew micrograms per hour, we only needed to do one additional step in Part B.